In this video, I'm repairing a staircase that runs down from the lounge area to the roof terrace. From the top, it did not look too dramatic. The stairs looked mostly intact, but underneath, the timber frame had been badly damaged by water. Water had got through the fiberglass covering and into the wooden joist below. Over time, the timber had completely rotted away. The stairs were soft underfoot, spongy in places, and it was bendy to walk on, and basically had very little strength left. So this was not just a quick patch or a bit of sealant, the whole internal structure needed rebuilding. The plan was to cut away the fiberglass outer shell, remove all the rotten timber, rebuild the frame underneath, refit the fiberglass, and then seal everything properly so water could not get back in. The first job was cutting into the fiberglass covering. I used an angle grinder, a corded one, to start cutting around the corners of the staircase. At first, I thought I might be able to remove the outer section in one piece, but that idea disappeared pretty quickly. The structure was big, awkward, and heavier than expected. I also did not fully know what was underneath it yet, so ripping it out in one go would have been a bad move. Instead, I cut the first step away separately, and that gave me a better access and let me see what was actually going on inside. But once the first section was open, the damage was really very obvious. A lot of the timber had lost its strength. Some of it was so rotten it could be pulled away by hand. Other sections had to be broken out more carefully. At this stage, the aim was simple. Remove as much rotten timber as possible, but keep the fiberglass shell intact, because I wanted to reuse it later. That meant I could not just smash everything apart, as maybe I'd like to have done. I had to work around the existing shape and clear it out properly. I also kept the work area as clean as possible while doing this. Rotten timber, screws, nails, and sharp offcuts can often turn a small job into a painful one. So as pieces came out, they were cleared away. Once the rotten timber was out, the next task was to measure up the new timbers. Normally when you replace timber, you can copy the old piece, but here the old timber was far too gone. There was nothing reliable left to use as a template, so everything had to be measured from scratch. The goal was not to redesign the stairs, the goal was to rebuild the internal frame so the original fiberglass shell could sit back in the same position. That meant the new timber had to match the old shape as closely as possible. Length, height, angle, and spacing all mattered. The other important part was retaining the required gradient of the stairs to allow water to run off. Because this is outside, the steps cannot be completely flat and they need a slight slope for rainwater to run off. Standing water is exactly how this sort of damage starts. Once water finds a small crack, seam or unsealed edge, it slowly works its way in, then the timber underneath starts to rot and eventually the whole thing loses strength. So every timber had to be cut and adjusted individually. The frame had to be strong, but it also had to keep the right slope for drainage. I used a circular saw to trim each piece down. A bigger workbench and a better clamping setup would definitely have made my life a lot easier, but sometimes you just have to make do. The important thing was getting the height right. If the timber sat too high, the fiberglass would not fit back properly. If it sat too low, the step could feel hollow or weak. Once the first layer of timber was in place, I covered it with OSB board, which matched what had been used originally. The OSB was cut to size, placed across the new timber supports, then drilled and screwed down securely. This created the base for the first rebuilt step. The key here is support. The board needs to be properly supported underneath. If there are gaps below it, it can flex, and when someone walks on it, that movement can crack the surface above, and once water gets through, the same problem starts all over again. So the strength is not just in the top board, it comes from the frame, the board, and all the fixings working together as one solid structure. After the first step was rebuilt, I repeated the same process for the next section. More timber was cut to size, adjusted for height, fixed into place, and set with the correct form. Then another board was fitted on top and screwed down. At this point, the staircase was starting to feel like a structure again, instead of a rotten shell. The final section needed extra attention because this had been one of the weakest areas before the repair. For this part, I used a thick 25mm plywood board. I wanted this section to feel especially solid because it takes a lot of foot traffic. The side fascia boards were also cut and fixed into place to close off the edges and support the shape of the structure. There was also a bit of rain during the job, because obviously working outdoors loves to make your life difficult. When you're working with timber outside, moisture is always the enemy. You do not want to trap water inside the structure before sealing it. Once the timber frame was rebuilt, the fiberglass sections could go back on. The bottom sections were refitted first, then the remaining section was added separately because that was the piece I had cut away at the start. Everything had to be lined up properly before fixing it down. The fiberglass needed to sit flat on the new timber frame with no major gaps and no loose areas. Once it was in position, it was glued, fastened and secured. This part matters because if the fiberglass moves when someone walks on it, the seal will eventually fail. Movement is what opens up joints, cracks sealant and lets water back in. Then came the final stage, sealing. This is probably the most important part of the repair. The timber gives the staircase its strength, but the sealing protects that timber from water. Every seam, joint, and edge where water could possibly get in had to be sealed. I used a specialist roofing tape designed for outdoor weather protection. It has a slow setting time, but once it bonds properly, it should create a strong weather seal. For the smaller gaps and finishing areas, I used an outdoor sealant in the colour close to that of the stairs, so the repair blended in as much as possible. The whole point was not just to make the stairs strong again, it was to stop the water getting back into the timber underneath, because once the seal fails, the timber fails, and once the timber fails, the staircase is finished. The reason I went with this method was because at the start, I didn't know what material I was dealing with. When I first cut into the outer skin, a strange dust started coming off it. Once the outer layer was opened up, it became clear that the structure was fiberglass. I could have completely rebuilt the fiberglass staircase from scratch. That may have been the more textbook approach, and maybe even the cleaner option in theory, but in reality, it would have taken a lot longer, cost a lot more, and there was no guarantee that the final finish would have looked as good as the original. So I decided to keep the existing fiberglass shell, rebuild the timber frame underneath, refit the shell, and seal everything properly. And the repair has really held up well. A couple of years later, and after several winter and summer seasons, the stairs are still solid. That is the real test with outdoor repairs, because rain, heat, cold, and movement will expose a bad job very quickly. So overall, I'm happy with the result. The staircase is stronger, the original finish has been kept, and the whole structure is now properly sealed and protected from the weather. If you find this video helpful, please like and subscribe.